I've been living in this bayou all my life. My family come here way back. It's a nice place, the bayou. She can be peaceful and quiet, except when the hurricane come. Wind, water, and rain like you wouldn't believe. So we build a levee to keep the flood water out. But sometimes even the levee don't work. The last time a hurricane come through, these houses get 8 or 7 feet of water in them. But we fixed that now. We building a new, higher levee. That's my job. I work on the crew to build the levee. I built lots of levees before, but this one's gonna be different. Some fellows come down here and say they got a better way to do it. They're gonna use Tensar. They joke and say they're gonna show us how to walk on water. They don't know this old bayou. This old bayou is tough.
When you live in South Louisiana, hurricane tidal surge is something you have to deal with on an annual basis. My name is Chip Cahill. I'm the president of the West Jefferson Levee District. We're building a $300 million project to protect billions of dollars of property south of New Orleans. One of the problems we have with this project is that we have to build levees where there are areas of very poor soil stability. That's where the Tensar geogrid comes in. We used this in our project and it was very successful. We're going to tell you a little bit about that now.
Soil conditions here are truly tough. Some would say impossible. More water than soil. After rain, a man can sink to his waist. Construction's almost impossible. In fact, it's common to lay 20-foot thicknesses of fill to achieve a crest elevation of 10 feet. A technique that can build a firm foundation here will work anywhere, from the easiest to the most difficult sites, even those that were considered economically undevelopable. We came here to prove that Tensar geogrids can meet the challenges of even the toughest soil conditions. The first task we faced was building an access road from the old levee to the new levee site. The site had already been cleared of trees using a crane mounted on a wide-track swamp buggy. The first morning, more than a dozen trucks full of river sand were backed up and waiting to dump their loads of fill for the access road. And everything was held up for the survey team. They were struggling to place the slope stakes for the haul road. After the rodman had taken 15 minutes to move through this muck, we suggested to the crew chief that he roll out some Tensar geogrids so the rodman could just walk out and place the stakes. The chief looked at us like he thought we had a few loose parts between the ears. After about another 20 minutes and the rodman moving another 15 feet, the crew chief came over and asked us to show him our suggestion. 2 men rolled out the grid, walking on it all the way. In less than 3 minutes, they covered 5 times the distance the rodman had taken a half hour to cover. And soon everyone was out walking on the grid, even in street shoes, saying things like, "This is amazing." Everyone, that is, but this one big Cajun we call Bubba.
No, that ain't right. We call him Big Bubba, because he weigh about as much as 2 regular people. Bubba say he's not walking on this grid. He say if he go out there, he sinks so deep they never gonna get him out. But this fellow from Tensar, he said, "Bubba, you sink in, and I buy you the biggest steak in New Orleans." All 300 pounds of Bubba was out on that grid in about 2 seconds. He walk on the edge, he jump up and down. But no matter what he do, Bubba don't sink. That Tensar passed the Bubba test.
From that point on, it was easy. The sand trucks came in and the first fill lifts were spread by a light dozer. We soaked the sand with water spray to assist in compaction, then the loaded dump trucks rolled right out onto the site, with only about 2 feet of sand and a layer of geogrid between them and the muck. Muck which wouldn't support a man's weight. But I can't put it any better than the way Jim Jones, the job foreman, said it.
We have put in approximately 50 trucks, tandems, a day out here. Had no problems with backing it up on this muck and mire that we have. It has held up extremely well. I'm very pleased with what I've seen so far. I think the stuff is amazing to me. I've had a lot of people come out here and see what's going on out here. And when they've seen the conditions of the construction going on and so forth, they've been amazed with it. And my people in the front office are extremely happy with what's going on.
So Tensar geogrids met the challenge. A layer of geogrid, covered by about 2 feet of compacted river sand, has converted terrain too weak to support a man's weight into a firm base, strong enough to bear the load of bulldozers and repeated truck traffic. But you might wonder what other techniques have been tried in these conditions. Would a high-strength geotextile work as well? So we thought we'd see for ourselves. It took 6 men to position the geotextile. Rolling it out straight was almost impossible. And in the really soft areas, the crew found themselves in a bit of difficulty. With GeoGrid, it was a different story. Only 2 men were needed, and it supported their weight with ease. You could imagine how difficult it would have been to try to sew the fabric under these conditions. On the actual levee construction, 1 man could position the grid, 2 roll it out and overlap it. Unlike geotextile, no sewing is required. As the actual embankment for the levee was raised, Tensar geogrids were used to reinforce the embankment, allowing for steeper side slopes and a 40% reduction in levee width. The conventional design called for a 224-foot wide levee. By reinforcing with Tensar geogrids, the levee width was reduced to 136 feet. The result was a savings of 100,000 cubic yards of fill per running mile. And settlement of the geogrid reinforced levee has averaged less than 30% of what would be expected if it had been built by conventional techniques. So, a higher levee and a better measure of flood protection is maintained with less labor, materials, and man-hours. Not counting the savings in right-of-way requirements, fill savings alone have been estimated by the state to approach $700,000 per running mile of levee. But hold on here. You're probably thinking, how can one be sure that the sand and bayou mud aren't intermixing? Well, we saw for ourselves, even in the worst-case scenario after some heavy rains. But what about after repeated truck traffic? The excavation for this settlement plate gave us an opportunity to look. There's no contamination of black bayou mud within the light brown sand all the way down to the Tensar geogrid. The sand is still dense and holds a vertical scarp all the way down until water just above the Tensar geogrid begins to seep into the excavation. How is this possible? The answer lies in the combined and simultaneous effect of pressure reduction, particle confinement, and particle filtration. Pressure reduction. Pressure reduction is made possible by the snowshoe-like stiffness of Tensar geogrid, be it under a man's weight or beneath heavy equipment. Less pressure means less water force to dislodge fine particles. Particle confinement. Much like these billiard balls are confined at their base and thus stabilized under an applied vertical load by this setup rack, aggregate fill particles are confined and stabilized by Tensar geogrid. Confinement ensures that openings are fixed and predictable in size, an essential requirement of filtration. Particle filtration. A pea just barely fits through this opening when the billiard balls are confined. It could be much larger, say marble-sized, if not. That is, if the balls moved under load. This size ratio, pea to billiard ball, is fundamental to filtration. So, just as anything larger than a pea cannot physically pass through the openings between billiard balls, fine soil particles cannot pass through aggregate fills that have been sized or graded to create sufficiently small openings. Fortunately, design aids and assistance in applying them are readily available to help one make informed decisions about reinforcement, separation, and filtration. Put simply, Tensar geogrids provide tremendous value in any construction over soft soil. By distributing the load over a wider area, confining the fill and improving compaction, Tensar geogrids speed construction, saving as much as 50% of the labor cost and equipment time. Improve site access and reduce downtime. Reduce fill requirements, and allow the use in many cases of inexpensive locally available fills, rather than precisely graded aggregates. And the Tensar engineered advantage extends beyond the construction phase of structures built over soft soil. It applies to long-term serviceability performance too. Westminster Levee, situated in the heart of the West Jefferson Levee District, continues to outperform all other comparable structures in the district, both in terms of total and differential settlement, and that means less maintenance costs for the taxpayer.
In 1987, the West Jefferson Levee District, along with the United States Army Corps of Engineers and Louisiana Department of Transportation and Development, through Tensar, developed this new technology for building on top of soft soils. The geogrid was used in this Westminster levee, and it's been very successful. The Westminster levee project was successful because the levee settled evenly thanks to geogrid. An excavation showed that there was no soil contamination. This product works, and we're proud of it.
Wait, I guess this old bayou not so tough after all. At least not so tougher than Tensar. These folks around here are not gonna have so much to worry about next time the hurricane comes.